Hi guys, I'm Kurt VanDusen, founder of Equational Applications LLC, and we're going to have another look at ViroReact augmented reality today. We're using the Viro community package on GitHub, and we're going to look at using a reticle to place our 3D object in augmented reality. So what a reticle is it's a square that you would have on your center of vision on your phone. So wherever you look in augmented reality, this square should track, and it's looking for a plane. And when it finds a plane, it should display the square on top of the plane so that you know where the object is going to appear. And in this example app, you just tap the reticle square and it'll place a beating heart. You can search for Viro Community Samples GitHub. Clicking on Samples repository. Under the code button here, I can copy. So I'm going to use this SRC folder that I've created to clone that repository. So I can open a terminal inside of that folder. And here I can use the command git clone. Of course, you'll need git installed on your system. CD samples. Well, let's do ls cd ARReticle. We can take a look at the README. npm install. npx pod install. I'm using iOS, so I can use the pod install. If you're on Linux or Windows, I don't believe you'll be able to do that. Now to run the app that we just downloaded, we're going to need a device, a hardware device, because ViroReact only runs on a hardware device and not on an emulator. If you want a reference for running on your physical device, just go to reactnative.dev and look up running on device. We're on the page here. We'll just scroll down a little bit. And on Windows or Linux, you might have to use the ADB reverse command. Here's a reference for ADB reverse. An issue I had one time on my Linux machine was because of a permission on my Gradle wrapper, and just running chmod 755 Android Gradle W solved that problem for me. I have an Android device, so I have to have my Android developer options enabled. And you can just Google Android developer options to find out how to do that. I have a USB cable attached to my, and then I click allow. Next, I'm going to use npx react native run hyphen Android. This new window that popped up has Metro running in it. Metro is serving the JavaScript bundles to the app that's going to run on the hardware device. This other window is continuing to run the Gradle daemon. So it's basically building the app to send it over to my Android phone. Great, build successful. So now you can see in the other terminal with the Metro server, we have index.js being served to the phone through the USB cable. And now my phone is asking me if I will allow the app. And I click allow. Now let's open up VS Code or your choice of IDE, and we'll open up the samples folder that we just cloned, and then we're going to open up ARReticle so that we can explore the files. App.js, safe area view to wrap AR Scene Navigator. And so this is just making sure that we're not using parts of the screen that are reserved for the cutout on a camera or something like that. And then Viro AR Scene Navigator is the entry point for the AR from Viro. It's getting Scene AR. In the root directory, we have scene AR.js. So let's take a look at that next. We're importing what we need here at the top. Created a class in this case. All of this for our state. We're mainly trying to learn about the on-camera hit test, which is used to place the reticle. And the reticle is going to be a reference for where we place our object. So display hit reticle false to start out with. Found plane false. So once we find the plane, then we can display the hit reticle. We start out with a reticle location of 000, which is right where the user is holding the camera. We're returning a scene that's going to be used in our app.js that we just looked at. We're creating a little bit of light to work with. And right down here in the scene, we are using get scanning quads and get model. What's that mean? It means that we have a function here called get scanning quads, and we have another function called get model. Inside of get scanning quads, we're returning basically a Viro node that holds the reticle. And the reticle is scanning for a plane. And when it finds a plane, it's going to allow you to click to place. Okay, here it is from Viro AR Scene. We are using on-camera AR hit test and on tracking updated. So this is the feedback that ViroReact is giving us. It's giving us feedback from camera hit tests and whether the tracking for AR is working. So here are the callback functions that we can use for that. Let's look at on-camera AR hit test, because that's the the one that's going to allow us to put the reticle right on top of a plane. On camera AR hit test, we designed a callback function, and inside of this function, we're running a loop, and it's an if loop, and we are basically starting at I equals 0, and we're going up until we find something where the AR hit test returns the result type existing plane using extant. And once it finds this, that tells us we found the plane. So now we can set state of the plane reticle location, and we're going to use this position that we've just obtained, and then now we can display hit reticle true because we found a plane, and we did find the plane, so that's true. And we're going to update the last found plane location as well. So now let's go back to get scanning quads function and look at that. You can see here that it's going to use ViroImage to display basically what is a PNG image file when the plane is found, and when it's not found, it's going to display sort of a dotted line version. So when it's a dotted line, we'll know it's not yet found the plane, and when it turns solid, then we'll know it has found the plane, and at that point it will also tell us click to place, and that's when we can click it. Once we click it, we go to on-click scanning quads function, and the on-click scanning quads function is just it's just going to say is ready true. So once is ready is true, then get model will be able to display its object. It becomes visible when this state is ready is true. So that's sort of a basic rundown of what's going on with using a camera hit test in order to place a reticle so that we can use that reticle for the user to place the object. All right, thanks for listening. I hope you enjoyed the lesson, and I'll see you soon.